So now we turn from our polynomials to look at limits with rational functions. So polynomials, we again mentioned, are dominated by their leading coefficients, their largest power. So we're going to now turn to rational functions where we have one polynomial over another and look at limits as we go to positive or negative infinity. So let's begin with this example here. Limit as x goes to infinity of x squared plus 7x over 4x squared minus 3x plus 4. We know the top will be dominated by the leading term, x squared. That's going to go to infinity. The bottom will be dominated by the leading term, 4x squared, largest power. That's going to go to infinity. So this is actually an infinity divided by infinity limit, which is also indeterminate. So we have to find another way to handle it. And the key idea is still this limit right here. Limit as we go to infinity, or negative infinity again when it's defined, of a number divided by a power of x is equal to 0. So what we're actually going to do here is we're going to multiply both top and bottom, or alternatively divide both top and bottom by the largest power of x that's present in the whole fraction, which in this case is x squared. So I'm going to multiply by 1 over x squared in both the top and bottom, or alternatively divide both top and bottom by x squared. And so we go ahead and do that, writing out all the detail here. I would get x squared over x squared plus 7x over x squared in the top. And then in the bottom, I'd have 4x squared over x squared minus 3x over x squared plus 4 over x squared. And then I just want to go through and simplify. So x squared over x squared will just be 1. 7x over x squared would simplify to be 7 over x. And then we move down to the bottom. 4x squared over x squared will be 4. When we get to 3x over x squared, when we simplify, that would be 3 over x. And then plus 4 over x squared. Now the reason that we did this was so we can bring this limit into play. Because now we have a lot of terms here that involve division by a power of x. And each one of those is going to go to 0. So 7 over x is going to go to 0. 3 over x is going to 0. 4 over x squared is going to 0. And so that leaves us with just a constant 1 in the top and a constant 4 in the bottom. And so the overall limit is just that, 1/4. Now this is the way I do each of the problems in the notes, but there is another way to do these problems, and I actually want to show that to you because we can go back and leverage our idea that the only thing that really matters with a polynomial in the top is the leading term, the largest power. And same thing for the denominator. So there is actually another way to do these a little bit quicker. This is kind of the standard calculus way, and this is also what I do in the notes, but I'm going to show you another way. So let's consider another problem here. Limit as x approaches negative infinity in this case of 5x squared plus 7x over 4 minus x cubed. So we could do the same thing here, divide both top and bottom by the largest power present, which is x cubed, and we could work through the problem that way. But here I'm going to approach it a little bit differently. I know for that polynomial in the top that the dominant term will be its largest power. So when I'm dealing with a limit going to either positive or negative infinity, all that really matters is that dominant power. So on the top, I'm just going to look at the 5x squared. And on the bottom, all I'm going to look at is the dominant power, which is minus x cubed. And then we can work this limit out. 5x squared over negative x to the third. We can simplify that fraction, 5x squared over negative x cubed. That will give me negative 5 over x. And now I'm dealing with a number divided by a power of x. And as I approach positive or negative infinity, as long as it's defined, which it is, then that's going to become 0. Oops, it looks like my problem got ahead of itself. On to the next example. I didn't have my pause break in. Okay, and I want to consider one more here. So notice in the top problem here, I could have written this in a simpler form as x squared over 4x squared. Simplified that to be 1/4, did the limit, and got 1/4. And you can see that this approach is a whole lot quicker and involves a lot less writing and computation. We're going to see the same thing here in this last example here now. Limit as x goes to infinity of 4x minus 3x squared all over 5x minus 7. So once again, all that matters is the leading terms. All that matters are the leading terms in the top and bottom. So I could rewrite this as limit as x goes to infinity of minus 3x squared over 5x. And now I can simplify that fraction. The x will cancel out, and I get limit as x goes to infinity of negative 3x over 5. And now as x goes to infinity, that's going to become infinity. And then times a negative 3/5 is just going to make it negative infinity. And so here we have a situation where we're approaching negative infinity. Okay, so these are limits involving infinity or, as we did in the second example, minus infinity. And with rational functions, we can actually use this shortcut to actually make these turn out to be fairly basic, easy problems. Or at least easier than what they would be if we did them the long way.